Good morning, my fellow scientists. It is Tuesday, August 22nd, 2017, and today I want to try to describe a concept called the propagation of error with cake. I've been trying to think of a way to explain this in a way that's intuitive and that uses something we're all familiar with. Hopefully we're all familiar with cake. So what is the propagation of uncertainty? The propagation of error? The idea is that if you take a process and break it down into its steps, every step has some variability, and when you add those variabilities together, you end up with the final variability in the product. So imagine that you have a recipe that has ingredients. You follow the recipe, you measure, you weigh, you mix, then you bake, then you take the product and you evaluate it in some manner. So let's imagine you're trying to measure cake moisture. Obviously, moist cake is better than dry cake. So we taste a cake and we ask, how moist is it on a scale from 1 to 10? And if we make the same recipe, same mixed ingredients, same baking procedure, everything's the same, ideally we would end up with 777 for the same recipe. But if we don't, if we end up with 5, 6, and 7, it would be really useful to know what part of the process was delivering this spread of results. Was it our ability to discriminate? Our taste? Maybe we're just not very reliable at tasting moisture. Or maybe it was the mixing of the ingredients that we're not very reliable at mixing ingredients precisely. Or maybe it was the oven. Maybe the oven is just not very consistent from bake to bake. How do you analyze that? And why is it that the product is reflective of all of the uncertainties in all of the steps? For me, intuitively, it makes the most sense to break this down from the end back to the beginning. So first we ask, am I as a taster reliable? If I taste 3 pieces of identical cake, do I actually give identical answers? This is the uncertainty in the evaluation or in the measurement. If I taste the cake and it's all the same cake and I still give answers that are very inconsistent, that suggests that the inconsistency is just in that last step, or at least the last step is contributing significantly. If that's not contributing significantly, we can move back to the penultimate step, say the baking. So if you take the same batter and bake it 3 times and then evaluate with a reliable and precise instrument instead of maybe my tasting procedure, the instrument might reflect the difference in its own uncertainty and the uncertainty of the baking procedure. So if the baking procedure is giving inconsistent results despite being the same batter, you get both of those uncertainties compounded. You get the uncertainty in the baking and the uncertainty in the evaluation. We can push this back another step, right? We can say, what about the mixing procedure? If we took the same ingredients and mixed them several times, propagated that through the whole rest of the procedure, that would undoubtedly end up making less consistent cake. How much did that part of the process contribute to the uncertainty? And we can push it all the way back to the measurements, the measurement of the ingredients, the sampling of the ingredients. Every step in this process is making the cake less consistent. Now, this is getting very meta, right? We're now measuring the measuring process. And I think that's where people get really thrown off. The propagation of uncertainty is this notion that we can quantify our quantification method. Oh, that sounds really horrible, but it's not. You can say, how reliable is my tasting or my moisture meter? Then you can ask, how reliable quantitatively by actually assigning a number of reliability, a reliability index. We can ask, how reliable was my baking procedure, my measuring procedure, my mixing procedure? Every step can be quantified in terms of its reliability. I don't think that's terribly crazy. So now the question is, what is that measure? The answer is usually standard deviation. So you take the same process, you do it multiple times, and you look at the results, and you compare those to each other in a way that says the more different they are from one another, the bigger the number. So smaller numbers mean more precision, more reliability. What's crazy is that that number, when you assign it to all of the different steps along there, oh, my measuring procedure had this precision in terms of standard deviation. My mixing had this standard deviation. My baking had this standard deviation. My moisture meter had this standard deviation. You can add those up mathematically to get a very good prediction of the standard deviation of the final product. So yeah, that's a 20-minute lecture distilled down to hopefully 4 minutes. If you like that kind of thing, tune in tomorrow. We talk more about chemistry and chemistry concepts and try to put these hard ideas into simple terms with cake here in the Allen.